Good day, my name is Bawa John Agmada and I'm doing a presentation on effect of indoor operational environment on workers' well-being in industrial buildings, a case for pharmaceutical factories in Nigeria. The primary objective of a building is to provide a sheltered housing that is comfortable, convenient and safe and even attractive to its users. Although the pharmaceutical factory is not just any other building because it houses the drug production process, hence it's built to be safe, to be serene, and a controlled indoor environment. Indoor air has a large share of impact on the building and its inhabitants compared to outdoor air, and this is largely due to the composition of both biological and chemical contaminants that are suspected to be therein. Chemical components or contaminants include carbon monoxide, carbon dioxide, asbestos, as well as construction chemicals. Biological contaminants include even pastes, dust, and even houseplants. And it's been proven that these contaminants can cause a wide range of sicknesses, including the sick building syndrome. Indoor air quality is found to be important to the health and productivity of the building users. And researchers have agreed that air pollution is the biggest environmental health problem in the world. Air pollution leads to a wide range of health challenges, climatic and ecological issues. It contaminates the air with a high amount of toxic air and particulate matter in the atmosphere. Researchers have defined workers' productivity as the amount of goods and services that the worker produces at a given amount of time as relating to the availability of raw materials, right tools or equipment, construction technology of the building where they work, the political factors, the financing, and the environmental factors. What contributes to workers' productivity is the workplace environment, and research has also asserted that among the factors that can influence work environment are morals among colleagues, increased stress, and a range of other issues. Lagos and Ogun State, Nigeria, or southwest Nigeria, were chosen largely because of the number of pharmaceuticals which are the highest in Nigeria that are located in those states. Handheld instruments such as multifunctional air quality detectors were used to carry out the measurements. These are some pictures of the instruments that were employed for this research. Sampling technique involved the selection of 4 pharmaceutical factories selected through judgmental or purposive sampling. Inclusive and exclusive criteria were used. Non-response rate prediction after the pilot survey was also used in the selection of the factories, and all the measurements were carried out at 15 points in the production areas of these pharmaceutical factory buildings. While they were fully functional, drugs being produced, workers working, and machines were running. Instruments were placed on a height of between 1 meter to 1.2 meter of height to maintain consistency. The pharmaceutical factories were categorized into 3, small, medium, and large, and the factors determining that included the number of workers, the number of drugs produced, and the size of the production hall. Correlation and strength of significance were carried out between the dependent and independent variables, where, for instance, the readings in red showed that there was a strong relationship and significance among these factors. For instance, air velocity was seen to react with particulate matter 1.0, and it was significant, and the relationship was strong and high. The ones in blue were significant, but the relationship, the strength were only moderate and not that high. The workers' productivity were also measured through the result of the group statistics. highlighting the productive and non-productive mean standard deviation and list-wise value of the variables considered in the survey. Also, this table shows the workers' productivity were also measured in respect to the relative humidity, which was found to be amongst the highest, air velocity, lighting, sound, and air flow was found to be the least. The test of equality of group mean was also carried out using the Wilks-Lambert test to measure the significance of each of the variables that were measured. Temperature, from between temperature up to sound were found to be highly significant, while from particulate matter to airflow were least significant. And then the standard canonic discriminant function coefficient was also carried out using the SPSS. The structure matrix was also arranged in the hierarchy of their influence and how they show the best predictor with coefficients beginning with total voltaic organic compound to formaldehyde to the particulate matter 1.0 and carbon dioxide. This result implies that each of the observed independent variables contributed to the dependent variables explanation in a significant way. The highest degree of relationship was indicated by total voltaic organic compound, though it was negative. The canonic discriminant function coefficient was also measured, and the coefficient of lighting, particulate matter 1.0, 2.5, carbon dioxide is 0.00, which implies that these variables affect workers' productivity in pharmaceutical factories, which is the presence of carbon dioxide is expected to be at 0.00 in these pharmaceutical factory buildings. In conclusion, therefore, the result of the data analysis showed a varied correlation between dependent and independent variables from factory to factory. The outcome was understandably so because all factories were producing different drugs at the time of the survey. For those that were even producing similar kind of drugs, for instance, tablet, it was unlikely that the same tablet was being produced, therefore different kind of chemical component and quantity was being utilized. And even if it was the same tablet, we saw that the conditions were not exactly the same, the number of workers were not exactly the same, and the size of the production hall couldn't have been the same. And the independent variables such as formaldehyde, total voltaic organic compound, and the 3 particulate matters were a result of the chemical contaminants suspended in the indoor air, as the quantity in use determined the rate of contamination. The source of carbon dioxide was mainly as a result of the workers inhaling and exhaling, breathing in the indoor environment. Therefore, the amount of dependent variable differ from factory to factories. Workers' complaint of illnesses were traceable to poor design features. Thank you for the privilege and thank you for your time.